Hello everyone, welcome back to Cloud Pedagogy. In today's session, we are going to learn about storage services. Next, we will go through the storage types on AWS. Finally, we'll understand how the storage services are in on-premises. So, we'll start with what are the storage services. So far, you have learned about compute and networking on AWS. Now is the time to move on the two other major categories, storage and databases. The student directory application that we are building out currently has a solid network in place using Amazon VPC and it's being hosted on top of Amazon EC2. The only issue is the app doesn't actually work because we haven't set up anywhere for it to store the student information or the student photos. In the coming videos, we are going to fix that. We will start off by learning about the different storage offerings AWS has and we will compare and contrast them. Then you will create an Amazon S3 bucket in your account that the student directory app is going to use to store the student images. Then we will explore the different database services AWS has and there are a lot. Though not to worry, we are going to focus on only two, Amazon Relational Database Service, otherwise known as ODS, and Amazon DynamoDB. You will then complete one final exercise by creating a DynamoDB table where the student information will reside. Now we'll understand what are the storage types on AWS. Again, we'll recap the architecture for our student directory application. We have created the VPC and launched the app on an EC2 instance. The next thing we need to configure is the storage. Our application requires several types of storage for its data. For one, we need to store the operating system, software and system files for our app. We also need to store static assets like photos for the student headshots. And then we have more structured data such as the name, job title, location of each student as well. All of that needs a home. The structured data usually requires a database, which we'll talk about later. So for now, we will focus on storing the application files as well as the static content. AWS storage services are grouped into three different categories: file storage, block storage, and object storage. First, file storage. You may be familiar with file storage if you have interacted with file storage systems like Windows File Explorer or Finder on macOS. You place your files in a tree-like hierarchy that consists of folders and subfolders. For example, if you have hundreds of student photos on your laptop, you may want to create a folder called Student Photos and place those images inside of that folder to organize them. Since you know these images will be used in an application, you may want to place the student photos folder inside another folder called student application folder. Each file has metadata such as a file name, file size, and date the file was created. The file also has a path, for example, computer/download/studentapp/images/student1.jpg. When you need to retrieve a file, your system can use the path to find it in the file hierarchy. File storage is ideal when you require centralized access to files that need to be easily shared and managed by multiple host computers. Typically, this storage is mounted onto multiple hosts and requires file locking and integration with existing file system communication protocols. Some of the common use cases for file storage include large content repositories, development environments, user home directories. Next, we'll understand block storage. While file storage treats files as a singular unit, block storage splits file into fixed size chunks of data called blocks that has their own addresses. Since each block is addressable, blocks can be retrieved efficiently. When data is requested, those addresses are used by the storage system to organize the blocks in the correct order to form a complete file to present back to the requester. Outside the address, there is no additional metadata associated with each block. So, when you want to change a character in a file, you just change the block or piece of the file that contains the character. This ease of access is why block storage solutions are fast and use less bandwidth. Since block storage is optimized for low latency operations, it is a typical storage choice for high performance enterprise workloads such as databases or enterprise resource planning systems that requires a very low latency storage. Next, what are object storages? Objects, much like files, are also treated as a single unit of data when stored. However, unlike file storage, these objects are stored in a flat structure instead of a hierarchy. Each object is a file with a unique identifier. This identifier, along with additional metadata, is bundled with the data and stored. Changing just one character in an object is more difficult than with block storage. When you want to change one character in a file, the entire file must be updated. With object storage, you can store almost any type of data, and there is no limit to the number of objects stored, making it easy to scale. Object storage is generally useful when storing large data sets, unstructured files like media assets, and static assets such as photos. I know you are still a little bit confused with block versus object storage. We'll try to understand more with an example. Let's say that I have a 1 GB file with text in it. If I'm storing this in block storage, what happens is that this file is split into fixed size chunks of data and then stored. However, in object storage, on the other hand, treats each file like a single unit of data. This might seem like a small difference, but it can change how you access and work with your data. For example, let's say I want to change one character out of that 1 GB file. If my file is stored in block storage, changing that one character is simple, mainly because we can change the block or the piece of the file that the character is in it and leave the rest of the file alone. Whereas in object storage, if I want to change that one character, I instead have to update the entire file. Let's take these two types of storage and access patterns and try to apply them to the data we want to store. For example, our static data like the student photos will most likely be accessed often but modified rarely. Therefore, storing it in object storage is fine. For more frequently updated data or data that has a high transaction rate like our application or system files, block storage will perform better. In this section of the course, we will discuss both block and object AWS storage services and how they will interact with our student directory application. I hope now you got a clear understanding of the block and object storage differences. Now it's the time to understand the traditional storage systems, and we also relate that to the cloud storage services. If you have worked with storage on premises, you may already be familiar with block, file, and object storages. Consider the following technologies and how they relate to the systems you may have seen before. Block storage in the cloud is analogous to direct attached storage or storage area network. File storage systems are often supported with a network attached storage server, which is NAS. Adding more storage in a traditional data center environment is more rigid process, as you need to purchase, install, and configure these storage solutions. But with cloud computing, the process is more flexible. You can create, delete, and modify storage solutions all within a matter of minutes. So that's all for today's session. When you're ready, please join me in the next lecture with a new topic. Until then, take care.